So some more examples of solving problems using density as an equivalence factor, something that relates mass to volume of an object. Once again, as with any problem solving, you do have to practice in order to get good at this and in order to get fast at it. Okay, so here's a problem. Ethylene glycol antifreeze has a density, so we know the density of the substance to be 1.11 grams per ml. We need to calculate its mass in pounds if the volume of the substance is given as 540,000 microliters. Please remember that prefix is a metric prefix called micro. Okay, so going back to the original formula of density being mass divided by volume, what would mass be equal to? Absolutely, mass will be equal to density times volume. So in this case, since we need to calculate the mass of antifreeze, we can take the density 1.11 grams per ml. So please remember, whenever you see units like that, grams per ml or miles per hour, the per means that it's for every 1 unit in the denominator. And then if you multiply this by the volume given as, also note how the specific way in which the volume is written, because that affects the significant figures in the number. Dot microliters. If we were to take density and multiply it by volume, we would be able to cross out the volume terms and be able to get mass. Unfortunately, here the units do not match up. So we need to take care of that, and that is the crux of this problem, is unit conversion to match those. So let's convert microliters into liters. Microliters, micro is a metric prefix where 1 microliter equals 10 raised to minus 6 liters. If you do it in this way, microliters cross out. And then of course liters can be converted into milliliters, because 1 milliliter equals 10 raised to minus 3 liters. Liters and liters cross out. Now, as you see, and of course milliliters and milliliters cross out too, leaving behind grams. In other words, mass. We have mass, but the problem is specifically asking for us to calculate mass in pounds. In other words, we do need to convert grams into pounds. So grams crosses out, leaving behind pounds. 1 pound equals 453.6 grams. When you do this calculation, the calculator answer would come out to 1.321428,571 pounds. How many significant figures do we need to write this answer in? Go back to the original data. Density is in 3 significant figures, but the volume, because of that decimal point in the volume is in 6 significant figures. So the answer needs to be in 3 significant figures. We need to round right there. 1.32 pounds of antifreeze with the density 1.11 grams per ml would have a volume of 540,000 microliters. So this has to be in 3 significant figures. Okay, going to the next problem. How many gallons of water will have a mass of 36.2 kilograms if its density is given? So in this case, mass is given and density is given. Going back to the original formula, if density is equal to mass divided by volume, how do we calculate volume? What is volume equal to? Yes, volume will be equal to mass divided by density. Now please use the units to make sure that you've set the problem correctly. If you have set the problem correctly, then you will end up with the correct units, otherwise not. Okay, so in this case, volume will be calculated by dividing the mass 36.2 kilograms by the density. Density is given as 0.9998. Now please notice how I'm going to write grams per ml. Now this is a denominator of a denominator. If it's a denominator of a denominator, I can write this as, and notice, 1 ml in the numerator, 0.9998 grams. We can't cancel out anything at the moment because the mass units are not the same. So how about we can convert one of them to match the other? It doesn't really matter which one. So grams goes on the top, crosses out, kilograms goes on the bottom, crosses out there. 1 kilogram is equal to 1000 grams. So we do have volume at this point. If you notice, the only unit left is mLs, that's volume, but we need to calculate the volume in gallons. So we need to convert milliliters to liters first, so that, and then liters can be converted to gallons. 1 milliliter equals 10 raised to minus 3 liters, and 1 gallon equals 3.785 liters. When you calculate the answer, the calculator gives us 9.5659818889 gallons. This answer needs to be given in 3 significant figures because of the kilograms, and therefore rounded right there to 9.57 gallons in 3 significant figures. Okay, let's read the next problem. Copper has a density, so we know the density of copper. They have specified the temperature at which the density of copper is 8.93 grams per ml because density is a function of temperature. It changes if you change the temperature. When a piece of copper whose mass is given was dropped in water in a graduated cylinder, the level of the water rose to 8.24 ml. What was the initial level of water in the graduated cylinder? Okay, so a little bit background information in this problem. What is going on here? If an object has a definite length, width, and height, or a definite radius, or definite dimensions, we can measure those dimensions and calculate the volume of that object. But what if you picked up a very irregular sized pebble off the street? How would you figure out its volume? Absolutely. You would do what the crow in the desert did, who was very thirsty. I don't know if you've heard of that story or not, but there was this crow in the desert. He was very thirsty and he came across this pot of water. The only problem was that the level of the water was way down and he couldn't reach it. So what did this clever crow do? He dropped in pebble after pebble after pebble into the pot. What was the effect of that? At every time he dropped a pebble into the pot, the level of the water rose a little bit. In other words, a certain amount of water was displaced. How much water is displaced? The volume of the water that is displaced equals the volume of the object that was submerged in that liquid. In other words, so let's say you have a graduated cylinder, which is nothing but a piece of glassware that is calibrated on the side and it holds a liquid. So if we had water in there at a certain level, let's call it X ml, and we dropped in a piece of copper, in this case, a chunk of a pellet of copper in this case, into that water, what will happen to the level of the water? The level of the water will rise to a certain value. And the idea is that this displacement, this rise in the level, this volume that is change that happens, this equals the volume of the object that was submerged in the liquid. So in this case, when 8,593 milligrams of copper was submerged in the water, the final level of the water, which means that this level of the water became 8.24 mLs. We need to calculate the original level of the water. So, what's the first step? The first step here would be for us to calculate the volume of displaced water, or in other words, the volume of this piece of copper. What do we know about copper? We know that its mass is 8,593. We also know its density at that temperature. So if we know mass and density, can we calculate volume? Absolutely. Volume will be mass divided by density. In other words, 8,593 milligrams divided by 8.93 grams per ml. Now grams and milligrams will not cross out yet, but we can convert them into each other. In other words, grams, milligrams, 1 milligram equals 10 raised to minus 3 grams. Notice grams cross out, milligrams cross out. We are left with mLs. When you complete this calculation, we get 0.962262038 mLs. If we round this to 3 significant figures because of density being in 3 significant figures, right there we get 0.962 mLs. In other words, when the copper block was dropped in the water, that is the rise in the level of the water. In other words, the initial level of the water can be obtained by subtracting the rise in the water level from the final level of the water that was reached. So if you subtract 0.962 from 8.24, we get 7.278 mLs. Now notice that in this case we've already rounded to 3 sig figs here, but we will have to round again based on the decimal places because this is a subtraction step. Remember I said previously that if the order of if the operations being performed are either multiplication and division only, then round at the end, the final answer. But then there are some situations like here where you do have multiplication steps, but you also have addition or subtraction steps. So we have no choice but to round twice. We rounded first for significant figures because that was the end of multiplication division, and then we have to round again based on decimal places because of subtraction. Now 8.24 has 2 decimal places, whereas 0.962 has 3 decimal places, so our answer needs to be in 2 decimal places, gets rounded to 7.28 mLs. In other words, the initial level of water in the graduated cylinder was 7.28, causing a displacement of 0.962 ml to a final level of 8.24 mLs.